One clue comes from the speeds of the motion we see. We know we have a red star and this mysterious gas cloud, and we know from the Doppler effect that they're going around each other at a speed of about 120 kilometers per second. We also know they're both going at about the same speed. When one's coming towards us, the other's going away, and vice versa. Now this tells us quite a lot. For a start, if they're both going at the same speed, they must be both going around a point that's halfway in between, which means they must have about the same mass. We can work out the mass of the red star by normal models of stellar evolution, and it's about the mass of the Sun. So we've got m's about the mass of the Sun. Mass of the Sun is written as m with an O dot below it, 0 with a little dot in the middle. So this cloud must also have about the mass of a Sun, 2 by 10 to the 30 kilograms, roughly speaking. But how far apart are they? We can also work that out. Now, because they're moving in circles at a high speed, there must be a centripetal force towards the middle of the circle to allow them to keep going in the speed. Whenever anything goes in a circle, there must always be a force towards the middle to hold it there, and that force is given by mv squared over r. Let's call this here r, the radius of the circles of their orbits. The distance between them is actually 2r. So for each object, we've got the mass, which was the mass of the Sun, times v squared over r must equal the centripetal force. Now what is causing the centripetal force? Well, it must be gravity between the two. So that's given by Newton's normal law of gravitation. So g, mass of the first object, mass of the second object, over the distance between them, which is 2r, squared. So that's balancing centripetal force against gravity. What can we do here? Well, we can cancel out one of the masses. We can cancel out one of the r's over there, and we end up with v squared equals g m sun over 4r. Now we know everything here apart from r, how far apart they are, so bring that up to this side of the equation. You end up with r equals g m sun over 4 v squared. Plug in the velocity of 120 kilometers per second, and that comes out as about 2 by 10 to the 9 meters. Now that's a very interesting number. The radius of the Sun is about 6 by 10 to the 8 meters, so that's only about 3 times the radius of the Sun. And red stars are bigger than the Sun, so that's telling us that the star and this gas cloud are actually very close together. If you're sitting on the surface of the gas cloud, the star will cover like half the sky almost. So this is not some distant binary. It's not as if you've got a star and a gas cloud a long way away. These are really up and almost touching. That's a really important clue.